Wouldn't it be awesome if you could talk to your database directly while coding and even have your AI coding assistant do all the work in your database for you? Well, now you can, with the help of MCP Superpowers. Let me show you how easy it is to get started with the official MCP server from Supabase to supercharge our development process in Cursor. Hey everyone, welcome back to Build with Grit. I'm Alex, and in our previous episodes we built an interactive dashboard using Norwegian police incident data, and then added a conversational AI that lets you ask questions about that data. Today, I figured it was time we have a look at some new MCP superpowers and how we can use it to supercharge our development workflow in Cursor by connecting directly to our data sources and tools. Specifically, we'll connect Cursor to our Supabase database with the brand new Supabase MCP server. We'll explore how we can do everything from Cursor instead of having to jump between Supabase and Cursor when working with our data. And I'll add a little bonus to the end and show you how we can use this with Claude, also for natural conversations about our data. Let's go. If you're not familiar with MCP, it's essentially a standard that allows AI systems to interact with external tools and services. Think of it as giving AI assistants like Claude or Cursor's AI hands to work with, allowing them to actually run code, query databases, or call APIs on our behalf. I'll keep this brief since I've created a separate video that goes deep into MCP. You'll find the link in the description below. The key thing to understand is that MCP provides a structured way for AI to interact with your tools and data, rather than just giving suggestions. Let's start by connecting Cursor to our Supabase database using the official Supabase MCP server. This will allow us to equip Cursor with a number of tools or abilities that it can use when developing against our Supabase data. There are over 20 tools available in the Supabase MCP server. First, let's open Cursor and look at how we can add MCP capabilities. Let's go to Settings and click MCP. Here, we'll see any servers that are already configured in our project, and we can add our new MCP server. It's fairly straightforward to add the Supabase MCP if you follow the instructions on this website. Let's just copy this and paste it into our mcp.json file in Cursor. Now all we need to do is generate a personal access token in Supabase and then add that to our config file here. Now we can see our Supabase MCP server is enabled and we can see all the tools available to our Cursor AI. Now we can actually have Cursor do a number of things, like for instance fetch data and run reports using SQL queries, generate TypeScript types based on our database schema, design tables and track them using migrations, and even retrieve logs to debug issues. We can also fetch project configuration and even spin up a new Supabase project or pause and restore existing projects. All of which previously required us to go from Cursor over to Supabase and execute commands or investigate and then report back to Cursor. So let's test this out. Let's start with something super simple. Tell me about what data we have in our Supabase account. All we need to do is allow Cursor to run these MCP tools. Now, this might get a bit annoying, so since we're only using the Supabase official MCP server, I will head over to Settings and enable YOLO mode for this MCP server. We'll find this under Features and Auto Run mode. Make sure that the MCP tools protection is turned off. Keep in mind that some of these tool calls will fetch data and can quickly fill up your context window, so make sure you choose a model that can hold larger context windows. Sonnet 3.7 is a good place to start. With MCP tool calls, you'll also hit this limit of, I believe, 35 tool calls. But if you switch to Gemini, you can actually do something like 300 tool calls. So let's try this. Tell me about what tables we have in Grit AI projects. Let us focus on the incidents table. What can you say about the structure? Okay, so now let's think about some real use cases when building and even vibe coding. Now, sometimes we have data and build something around that data, and sometimes we want to add a database to store whatever information our application is capturing or managing. In our case, we have incident data, and let's say we're now building our dashboard. We could then, for instance, ask Cursor to create our TypeScript types based on the data and start setting up our API to connect to this data and present it in our front end. Please create a TypeScript file for our data in the incidents table and set up a function to pull up the latest 10 incidents from this data and display it in a simple Next.js page. This would also be equally easy if we start with a simple app like this presentation playground, and we want to add a database backend to store these markdown files. Please set up a table in Supabase in my Grit AI projects called presentations for our markdown presentations in this project. Create the necessary TypeScript type definitions based on our data. We can then expand on this and build out the entire CRUD functionality to manage our presentations. Now, Cursor is not just giving me code suggestions, but actually executing SQL queries against our Supabase database in real time to help me write this code. This is incredibly powerful because the AI now has direct access to our schema and data, so it can write much more accurate and relevant code. MCP Superpowers. Let's try a few more examples to see what we can do. Can you create a function that returns all incidents of a specific type? In our police dashboard, I used functions for a few of our data statistics aggregations. Then I had to work with Cursor to create the SQL queries and then head over to Supabase to make it work. I spent quite a bit of time back and forth to get things like row-level security policies right. This now works like a dream, as Cursor can directly check and update the RLS to ensure that it works correctly. Notice how Cursor is able to query our actual schema in Supabase. It understands the data structure, it generates working code that's tailored to our specific database, and it can actually test it against real data to ensure that it works. This is dramatically more powerful than traditional AI coding assistants that are limited to generating code based only on what you describe in your prompt. In this video, we've focused on working with databases, and in particular Supabase, but there are so many more possibilities here to create powerful workflows in Cursor. We could, for instance, use the new modes in Cursor, combine something like Supabase with Figma for design, and adding browser use for seamless live browser testing, checking console logs, and so on. I'll definitely cover more MCP Superpowers in future videos. But for now, let's round off with a quick example of how we can also use this new Supabase MCP with Claude or any other AI assistant that supports MCP. I'll open Claude and add our MCP server. What can you tell me about the police incident data that I have in my Supabase project, Grit AI projects? Can you help me understand some trends in this data? What were the biggest incident categories in December 2024? Can you visualize the incident categories by month during 2024? Look at how Claude is now able to query our data directly through the MCP server. It can generate insights based on the actual data and answer follow-up questions with current information. This means we can have natural language conversations about our data with an AI that has direct access to the latest information from our database or API. No more outdated information or hallucination about what might be in our data. So that was a quick look at Claude, and in case you missed it, I actually made a whole video about talking with your data with Claude here. And there you have it. We've seen how MCP and Cursor can completely transform how we work with data during development. By connecting our AI assistant directly to our data sources, we can query our database naturally while coding, have context-aware conversations with AI about the data, and let Cursor do the work for us in Supabase. This approach doesn't just save time, it fundamentally changes what's possible when building data-driven applications. The AI becomes an active participant in our database work rather than just an advisor. In future videos, I'll definitely cover other powerful uses of MCP servers to further supercharge Cursor. If you found this helpful, please like and subscribe, and check out the dedicated MCP guide video linked in the description. Thanks for watching Build with Grit, and I'll see you in the next one.